and energy management that for the entirety of that time. The focus has shifted a little bit, but the main goal has always stayed the same. So very excited to share some of what we've been doing with you all. So I wanted to start with this, this definition of sustainability because it's always resonated with me. Sustainability is the ability to meet the needs of the present without compromising the ability of future generations to meet their own needs. And to me, the best way we can do that is to use less in everything. A couple years back, we worked with our communications department to come up with this graphic to talk about sustainability at KUMC. It's not just recycling, which is what most people think of when they hear sustainability. It's really encompassing of a lot of different aspects, including recycling, landscaping, energy and water conservation, health and wellness, diversity, inclusion, and transportation. Today, we're just going to focus on energy conservation because that is the aspect that I work on every day and I get to have the most impact on. So just to give you an idea of magnitude, this is a look at how we use energy on our campus. So in FY21, we spent just over 6 million, 6.2 million just on utilities for the main campus here, Kansas City, Kansas. The bulk of that energy consumption comes from electricity. So we use electricity not just for the plug loads, computers, electronics, everything you plug into the wall, but we're also using it to generate chilled water, which is what we use to cool our campus, and to power these great big fans, which is how we move airflow through our buildings. Next is natural gas, which is we produce steam at our central plant. Natural gas is the next biggest user of utility costs, but you can see it's pretty far behind electricity as far as scale. We use natural gas to produce steam, which heats our campus. That's how we keep our buildings nice and warm. And it's also how we run some process loads in our laboratory buildings like cage wash, autoclaves, glass wash. Then following that, we have water and sewer costs. These are utilities that I expect the cost to continue to rise in the future. So we're going to be putting a lot more focus on water and sewer costs moving forward. How can we reduce our water usage on campus? And then lastly, you see solid waste, which is removing trash from our campus. So $6.2 million. My job as energy manager is to bring that number down the best I can. And dollars equates to energy, which equates to how we impact our environment. The less energy we use, the less impact we have on our environment. So what are we doing? So I highlighted 5 things here, and there are many more than this, but these are kind of the 5 biggest. Upgrading our HVAC building automation system. We're going to talk about that a little bit more in detail. And HVAC is heating, ventilation, and air conditioning. So all the heating, cooling, and movement of air within our buildings. Lighting retrofits, everybody's familiar with LEDs. Then we look at solar and alternative energy sources, energy efficient equipment replacements, and water and irrigation management. So today I'm going to talk in a little more detail about 2 of these items that play the biggest impact, and then we'll quickly go over the other 3. So starting with everyone's favorite, solar panel at KUMC. Solar panels. We are the proud owners of 2 solar photovoltaic systems on campus. They both came into operation about a year ago now, just over a year. We have a 46 kW system on top of the health education building and a 54 kW system over at Landon Center of Aging, and that's the building on Rainbow and 36th Street, right on the corner. Between the 2 systems, we have about 300 panels, and that gives us about 130 megawatt hours of production every year. So we are producing our own energy. It's being used directly by those buildings as it's being produced. So when we wanted to look into solar, we went out to bid to get responses back from different companies who would provide the solar panels for us. We asked them to give us options for a lease agreement or for purchasing the panels outright. What we found when we got those responses back, that a lease agreement gives us the most beneficial option financially. So we could sell the project better if we went with a lease agreement. So we ended up with a company called MC Power who does solar panel installations all over the area. The annual lease agreement from year 1 was estimated to be less than what the panels would offset from our utility costs. So from year 1, we're in the black, we're positive financially. So we just finished up our first year of production. We spend about $12,000 a year in that lease payment, which is really not much, $12,000 a year for lease. It offset our utility costs by $14,000. So net, you're looking at $2,000, which doesn't seem like a lot. But these panels have a 30-year life. We have a 15-year lease. So we pay that $12,000 for the first 15 years. Electricity rates are going to go up year over year. So we get a little more savings incrementally because they're going to continue to produce. That savings number goes up a little bit more every year. And then at the end of that 15 years, those panels continue to produce electricity and we benefit from all that they produce without that lease payment. So over the life of the system, it's predicted saving of $276,000. Now, as we move forward, again, that's not going to sound like a lot of money, but it's something. It's a tool in our tool belt. So these solar panels produce about 20% of those two buildings' electrical needs. We will always use everything that those panels are producing. We're never sending anything back to the grid or selling energy back. Everything will be used. And to put that in reference, that would power, when all of the panels are up and operational, we could power 5,000 LED light bulbs with just those solar panels. So since we are focusing on sustainability, I do have to share, there are questions about how sustainable solar panels really are. They're pretty energy intensive to produce. The mining required to get the materials is pretty energy intensive as well. And there's still not great options for recycling and disposal of the panels at the end of the 30 years. So we just did a small project to put it in our portfolio. And I hope that in the future, there are some better options and that technology continues to get better and better. And then we can look at maybe expanding even further. So this is a snapshot of our solar dashboard. We have a web platform that we can log into every day and see what those panels are producing. So I grabbed this snapshot just 2 days ago. So it was a nice sunny day on the Landon Center building. We were getting almost our peak capacity. And we can very quickly see how well the panels are doing. We can see the production throughout the day. So you can see when it's dark outside, there's nothing. And then as the sun comes up, the power comes up, it lines up pretty nicely. But like I said, they are producing exactly like we expected them to. And so far, so good. All right, so the next one, it's a little bit nerdy, but it's my favorite. And this is the one where we have really focused in on here on campus, the HVAC building automation system upgrades. So what is a building automation system? Building automation system, you can think of as the brain of all of the heating, cooling, and ventilation equipment on our campus. Just like any other technology, there have been vast improvements over the last 15 to 20 years in those systems. And so there's a focus on energy efficient operation. So we're seeing huge improvements, huge reductions in our energy consumption in buildings where we upgrade the systems simply by doing the upgrade and nothing else. But in addition to that, the new systems give us the flexibility and the potential to do more specific operation of spaces. So I grabbed a snapshot of this building. We are right now in LEED ground floor. So this is what LEED ground floor looks like when we log into the building automation system. And in previous systems, if I wanted to turn off the heating and cooling at night when everybody left, I'd have to turn off the whole floor or the whole building. With the new system, I can look at room by room. So this GO32 seminar is where we are right now. And with our new system, we can turn off the airflow to that room anytime there's nobody in there. So we are only heating and cooling and ventilating that space when it's needed, which produces a considerable amount of reduction in how much energy we use. Another thing we considered when we looked at replacement of these systems, when we looked for a new system, we wanted to make sure that we were considering the lifespan of the equipment of the product we were buying. Historically, we had a system that would get, the company would replace the entire system every couple years, and they would no longer support the equipment that we already had installed. So instead of just doing a software upgrade, we're ripping out a bunch of electronic equipment and replacing that as well, which not sustainable or pulling out a bunch of plastic parts that can't necessarily be recycled, having to buy replacement parts, not a great solution. So we wanted a product that was going to be backwards compatible. Anytime there was a software upgrade, we wouldn't have to replace all the end devices. And this product has done that for us very well. So I won't go into a lot of technical detail, I'll spare you, but the idea here, this is an air handler in this building in Lead. So we have two major air handlers that provide air to the whole building. And each of these yellow numbers on this graphic is a piece of information that the control system is giving us. And so now we can intelligently make decisions about how to operate our equipment because we have all of this information. So we're not guessing whether a room needs heating or cooling. We know when it needs heating or cooling and how much it needs, and we can tailor our operation to meet the actual needs of the building. So not only are we saving a lot of energy by running our equipment less, the occupants are more comfortable because we're giving them what they need and not just what we think they need because it's 50 degrees outside. So this has been by far the most successful project that we've done in terms of energy reduction and energy conservation. We are in the process right now going building by building across the whole campus to upgrade these systems. We have a lot of legacy systems that were 20 plus years old. We are getting very close. We have a couple buildings left to do. I'm very excited to have that done. Some of you may have gotten a lot of emails from me when I upgrade your building saying we're going to be in your space, the HVAC equipment's going to be down. But just understand that this is why we're doing it. We're doing it to reduce our energy use on campus. So this is an old example, but I just love how clean the data is on this one. This is from back in 2015, School of Nursing building. We upgraded the control system in School of Nursing building in 2015, and that was really just a phase 1 implementation. We just did the big equipment and put it on this new control system. So if you look at the electricity consumption in the graph on the screen there, all of the blue curves are how much electricity that building used before that implementation happened. All of the red and orange curves are the electricity usage after that implementation happened. So that's a pretty good 30% drop in electricity by doing nothing else than upgrading the control system. So really fantastic results. And we actually just went through this building for the second round to take over all the remaining devices in the rooms. So ask me again in a year and we'll see another curve that should be a little bit further below that existing one. Laboratories on campus use huge amounts of energy. So if you think back to that $6.2 million that we spend on energy on campus, for a commercial building space, usually 50% of that is HVAC, heating and cooling ventilation. For laboratory, it's closer to 60+% of that energy use is for laboratory spaces. So we wanted to find a solution that really targeted our laboratories. And we started with Hemingway. Hemingway has a specific type of airflow equipment that allowed us to install a laboratory demand ventilation response system. So in laboratories, you have to replace all of the air in a room at least 10 times an hour. So all of the air in one room has to be dumped out and refilled 10 times plus. In Hemingway, some of the rooms were up to 15, 18 times an hour. And that's to flush any harmful chemicals that are used in the space, to make sure you're getting fresh air. And all of that air that's being replaced is coming from the outside. So that's, if you have a very hot day, a very cold day, that's a lot of energy that you have to use to take that outside air and make it a nice 55 degrees to send into your laboratory spaces. So huge hogs of energy. What this system does, it takes an air sample. So in every single laboratory room in Hemingway, there's a little plastic tube that comes from the room back to a sensor suite. And it's continuously taking a sample of air, sending it through a sophisticated sensor suite, and measuring it for volatile organic chemicals. And if that sensor suite says, hey, my air is clean, we can reduce how much airflow we're sending through that room. So instead of sending 10 to 15 air changes per hour, we can go down to 4 or 5. So we're cutting it in half or more. And again, any airflow you can reduce reduces how much heating you need and how much cooling you need. So the result is we can slow down our fans. We have massive fans that pull the air into the building and out of the building. We can slow those down. We can reduce how much steam we need for heating, and we can reduce how much chilled water we need for cooling. And the more we do that, the less energy we use. So we've seen some really great results with this project in Hemingway. Now for future buildings, for the other laboratory buildings, they unfortunately don't have that same equipment. So we can't necessarily do it in our existing laboratory buildings, but if we build more, that is a technology we would implement in any laboratory buildings to allow us to do that. So we talked more in depth about the two biggest ones, HVAC building automation systems and the solar panels. I just want to touch briefly on the other items. Lighting retrofits, obviously putting in LED lights is cost effective, and we are doing that with every remodel project that we do. Any remodel project also would have motion detection or occupancy sensors so that when nobody is in the space, those lights turn off. We're not using the energy. Another cool thing that we can do is tie in those occupancy and motion sensors to our building automation system. So newer buildings like health education building does this. If there's nobody in the room, I'm going to relax my set points a little bit for those rooms. So instead of cooling that room to 72 degrees, I might just cool it to 76 degrees because nobody's in there. And that's going to cut my utility costs. So some cool things coming with the occupancy and motion sensors that we have in place some places, but will continue to grow. Now, lighting retrofits on their own as projects we haven't focused on yet, and that's just because we know we can get the biggest bang for our buck with HVAC automation. And as we kind of finish up those projects, then we'll start looking at some bigger picture LED retrofits. We have limited resources, so we try and pick the most efficient, the most bang for your buck option. Energy efficient equipment replacements. Whenever we replace any of our large pieces of equipment, we're going to consider what the long-term operating costs of that equipment are. A lot of times the less efficient equipment costs more upfront. So it's easy to say, well, let's just buy the cheapest option. But when you look at the long-term costs, they're going to be more expensive. Most of our equipment now comes with variable speed options and other efficient options. We are always going to choose those because we know that the long-term costs are worth it. We're going to lower our utility costs, and that piece of equipment will probably run longer. Next, we have water and irrigation management. Our landscape department has done a really great job on this. They've been planting more and more native plants, which require a lot less water usage. So we're reducing how much water we're using, and they're also installing what's called a rainbird monitoring system for irrigation. So we're not using more water than we need to. We have sensors that tell us how much water we need, and we can water just that amount and not more. So some good things happening on water and irrigation management. Okay, so what's the impact? Those things all sound great, but what happens? So there's a lot of information on this slide. The blue bars will show you how much we spent on utility costs as an institution from FY14 through FY21. So you can see FY14, we spent just over 7 million. And then as we move year over year, it fluctuates a bit to FY21, where we're spending 6.2 million. Now, of course, our electricity rates are changing year over year. They're variable, they fluctuate. So hard to tell performance energy wise by just looking at the dollars we spend, because we don't have control over what electricity and what natural gas costs. So we created a model to say, how much energy would we use? How many dollars would we spend if we used energy at the same rate per square foot that we did in FY14? So if we didn't reduce our energy, how much would our utilities cost using the current year's electricity rates? And that's that red bar with the numbers next to it, is how much more we would have spent had we not done all of the work to offset energy usage. So you can see in FY15, we had a modest $302,000, all the way up to FY21, we are up to 2.2 million in reduced or avoided energy costs. So over the lifespan, FY14 through FY21, we are up to 9 million cumulative cost avoidance. And the reason we picked FY14 is because that's when we really started focusing on energy conservation. So FY15 was the first year that we had the energy management position. That position was created. And it's when there was a focus and resources put towards energy conservation. So that's why we chose that as the baseline. So to put that in perspective a little bit, for FY21, I said we reduced our costs by 2.18 million. The EPA has this nice tool that will calculate for you what that means in terms of carbon offset. So they use a CO2 equivalent calculation. So 174,000 MMBTUs is equivalent to 15,500 metric tons of CO2 equivalent. And that would be like removing just over 4,000 passenger vehicles driven for 1 year, 1.8 million gallons of, now that's diesel, but it is close to gasoline, consumed, removing 2,300 homes energy for 1 year. And this one I really like because I think it's a good visual, 106 rail cars worth of coal burned. So just last year, we were able to kind of pull that equivalent out of emissions, basically. So over the lifespan, EPA changed their icons. That's why they look a little different. Over the lifespan, we avoided 9 million, which would be 52,000 metric tons of CO2 equivalent. So that's 11,000 gasoline-powered passenger vehicles for 1 year, 6.6 thousand. Homes energy use, almost 6 million gallons of gasoline, and 291 rail cars worth of coal burned. So I think that's pretty good. We have a long way to go. We're going to keep moving those numbers, but we're very happy with the progress we've seen so far. I included this 2 million incandescent lamps switched to LEDs, mostly just as a justification for why we don't put resources there first. Because yes, it does save energy, but we know we can save more energy doing other things with the same resources. Any questions for me? Yeah.
So I got just on the subject of renewable energy. Yeah. So just on the subject of renewable energy, obviously, like you're limited by the infrastructure of like the Kansas City area at large. Is there any kind of initiative to work with the city to start switching maybe more larger infrastructure towards renewable sources?
That's a really great question. And I wish I had pulled some data on that. So BPU is our electricity provider, and they, in terms of electricity providers go, they are actually pretty good about pulling in renewable sources. I can't remember what their exact makeup is, but I think they were close to 50% renewables at this point. And we have worked with them looking at potential for partnering on solar farms. So BPU essentially would build the solar farms. We would agree to purchase a certain percentage of the power produced by those solar farms. And then we would be locked into that rate for the next 30 years. So it's something we have worked with them on. We could definitely do more. But yeah, and for solar, we had decided to do it. Yeah, we talked about those issues. But yeah, I absolutely think we could, and I think we could partner with the climate action group and see if we can get a meeting together. I think that's a great idea. Any other questions? Yeah.
So I really appreciate this information, Maria. I think it's fantastic what you're doing. And I also appreciate that sometimes to get things done, the conversation has to surround how much we're saving in finance. But what's interesting to me is what is completely absent from this is how much the greenhouse gas emissions from using so much electricity are impacting human health. And I would think at an academic medical center that we could help you, clinicians, if you're on the line, with how to ensure that that is always part of the conversation. And that's not necessarily for you to do individually. I just think that because we know that health systems are contributing so much to greenhouse gas emissions and that climate change is probably the biggest public health concern of our time. So I just think I'd like to comment that we should continue to work together to make sure that is always part of the conversation, how that is impacting human health. So.
Thank you. Yeah, I love that comment because, you know, like you said, I'm an engineer. That's all I'm thinking about, truthfully. But I would love to partner with you to learn that and use that to, you know, get the support to do more of these initiatives and to pull BPU in and to do just make it a bigger conversation. I think that's wonderful.
That's so true. I love that comment that she made. So if we could work together and just think of more ways we can reduce climate change and reduce energy emissions right here on campus, that would be fantastic.
Any other questions? Well, I included my contact info here. I would love to have like further discussions, and if anybody has any ideas about more that we could do, I am all ears. And yeah, looking forward to working with you all more in the future, and feel free to reach out if you ever have suggestions or comments, questions. I am all ears. All right.
I do have a question.
Mhm.
Hi. How does KUMC work with, or do you work with sustainability programs in Lawrence?
Good question. As far as I know, we don't have a big connection right now. I work with the energy manager at Lawrence. We share ideas back and forth and we touch base. But as far as sustainability on a bigger picture, I am not sure. And Shelley, I don't know if you have more information about, I know you've started partnering with them.
Right. I don't, you know, and that's one goal of this program is to see how we can work together with KU Lawrence and the community to bridge efforts to bring it together.
Yes, I would very much like to have that, because I'm looking at what you're doing and it looks pretty good. And I'm in Lawrence, but I know like my building, I don't know if you're familiar with the buildings here, but it is absolutely not climate friendly in any way, shape, or form. The radiators are still going in several of the rooms. So I think that it would be definitely worthwhile to brainstorm together at least. There's got to be a way.
Are there any easy hanging fruit that we can work on together, Maria, that can help? I'm even thinking of like our shuttle buses. Can we have them electrify them for both campuses? That would be an easy reducer of emissions. You know, it's not cheap, I know, but I think it would make up for itself in the long run as far as gas, with the price of gas, especially nowadays. But are there any things that we can do that are doable, like in the next 12 months?
Yeah, I think the best thing we could do is start those conversations. And if we can start partnering between us and KU and get all of everybody interested involved, we can come up with some of those ideas. Any other comments, questions? Should I hand it over to David? Well, thank you all.
Thank you, Maria. That was awesome.
All right, y'all. I just wanted to have this slide in here, mainly just to consolidate all the future dates for these conversations. So we will be continuing these until June. Then we'll take a break off in July and August, and then we'll kick back up in September and go all the way until January 2023. Importantly, because this is a joint effort between Lawrence and the Kansas City campus, we will be alternating the physical locations between KUMC and Lawrence. But the option to join virtually is always there, and it's the same way that you signed up for this event. If you would like to attend future events, obviously we're talking about a multifaceted issue of climate change sustainability. So we're trying to bring in as many different perspectives as possible. Obviously today we got the energy usage and the more infrastructure as a institution and what we're doing to mitigate climate change. But we have partnerships in the future with lobbying groups, with environmental justice groups, with sustainable food practice organizations. So just kind of covering a broad number of topics, hopefully to kind of integrate them together and us as a community between Lawrence and Kansas City to come up with some more integrated and holistic solutions. And then my bad. Okay. And the other thing I really wanted to talk about was the sustainability challenge that this grant also allows us to do, which is a community-wide challenge between Lawrence, KU, KUMC, and just the Kansas City campus. So essentially, it's just a way for people to submit ideas of things they'd like to do around campus and around their communities to make them more sustainable and environmentally friendly. And then applications will be released in May, and then I believe the due date will be sometime around July, and then the winner will be announced in October in the fall of next year. Importantly, our grant allows us to give out a $1,500 stipend to actually implement this idea, the one that we have selected, and actually provide like a tangible change. Sorry about the mic, by the way. That's a good question. I believe as of right, I'll have to talk more with the other people on this grant. I'm not sure. Dr. Bhattacharya, do you know if this is open to Wichita and Salina as well?
Yeah, I saw that in the chat. I've been thinking ever since that chat came up, that message. I'm definitely not opposed to it, but I'll need to speak with Dr. Lavin and Beto and see what our thoughts are. But since they're all part of the KU Med Center institution, you know, as far as our two satellite centers, I'm not opposed to it at all.
Yeah, and
I think it would be
someone in the
fine.
audience also made a good point. The KU Edwards campus as well could
Mhm.
potentially be another place
Sure.
to kind of implement this.
Right. And if I could add one thing to what David just said, is that the application will be released on the website, and that'll be through the QR code. So if you're wondering where that application will be, it'll be, once you get to the QR code, we're getting the application finalized and it'll be on there. And also, so you know, there is going to be another sustainability challenge launched for the KU Medical Center campus only. And that's funded by the KU Medical Center Facilities Management Group. So there are two potential opportunities for sustainability, which I think is fantastic. The more projects we have in sustainability, the better. This particular one that we're talking about today is open to everybody, all campuses, as well as the community. So for any of you listening that are not part of the campuses, you're invited with open arms to submit an idea. And it's open to all. And the theme, though, needs to be climate change and health.
So Shelley, one thing with the Wichita and Salina issue, I think we would have to ask the grantors as well. you know, what they could envision that scope to be.
Sure.
Yeah.
We can do that and ask them. That's a good point.
Okay, yeah, thank you. But yeah, like Dr. Bhattacharya said, is if you just scan this QR code, not only will you get information about future events and dates and basically everything that I just mentioned in my slides, but also you will have recordings of this presentation as well as future presentations as well. So yeah, thank you everyone for attending. It's really awesome to see people come out for something like this. It's an important topic that obviously everyone here is probably passionate about, and it's just really nice to kind of get these conversations going within our community. So yeah, thank you.
And please invite your friends and connections to join us for future events. I want to put a shout out to Tom Jacobs. He's part of our audience here. He's with Mid-America Regional Council. So it's a great community advocate that unites several counties, and they have the climate action project that they've spearheaded. So really getting the community involved and engaged is integral to making this happen. So please, let's work together and let's be a more sustainable campus as well as more sustainable community.
So yeah, this I wanted to give a shout out to the next one. It's going to be Dr. Mary Ann Jordan from KU, and she is going to be presenting planning and processes that are in progress to develop a natural dye plant garden at the KU Field Station Medicinal Plant Research Garden in North Lawrence. So it's an overall overview of the environmental impact of synthetic dyes and fibers and fabrics, and samples, dye samples and finished artwork by students and nationally known artists. So that's going to be on May 9th at the Commons. And again, it will be also accessible by video.
All right, I believe if there's no more comments or questions, we are finished with our first event. Thank you everyone again, really appreciate it.
Thank you all.